Hey guys, Dave Mazzetti here. Today I'm going to talk to you about distilling knowledge into tiny LLMs. Large language models are the magic behind AI. These massive billion and trillion parameter models have been shown to generalize well when trained on enough data. The big problem is that they're hard to run. So many just call LLM APIs such as OpenAI and Claude. Additionally, in many instances, developers spend a lot of time with complex prompt logic, hoping to cover all the edge cases and believe that you need a very large model in order to handle all the rules. The thing is, if you truly want to control your business processes, you have to run a local model, in my opinion. And the good news is that it doesn't have to be a giant and expensive multi-billion parameter model to do it. We can fine-tune tiny LLMs to handle our specific business logic. This notebook is going to go ahead and give you an example of how to do that. So the first thing we'll do here is install TextAI like all these notebooks along with the datasets library. And then the LLM that we're going to use is a 600 million parameter Qwen 3 model. So TextAI has an LLM pipeline. They can easily load anything from can load an API. It could load OpenAI, but also could load Llama CPP, it could load transformers models and much more. So definitely take a look at the LLM pipeline. It's pretty flexible. In this case, though, we're just going to load a transformers model from the Hugging Face Hub, Qwen 3 0.6 billion, 600 million. So let's just see how this model works outside just by itself. The base model will run a prompt translate the following request into a Linux command and only print a command. And then the command, what we're going to do, the English version of it is find the number of users logged in. So we run that, go ahead, and it comes back with PS-E, which definitely is not what we're looking for. But as you can see, it at least understood that you want to create a Linux command. So it's somewhat close to it, but we're only working with 600 million parameters, so you can't expect it to generalize to everything. That's where fine-tuning or distilling knowledge comes in. So as I said, 600 million parameters is small, and we can't expect it to do everything, as I said. But let's give this a try and see if we can actually inject knowledge into this large language model and get it to work the way we want. So we're going to go and create the same prompt template for all the data, translate the following request into a Linux command, only print a command, and then we'll plug in the training data there. We're going to use a training data set, this one right here, Linux command data set. We'll load it from the Hugging Face Hub, and then we're going to map each row. It has an input and an output, which input is the English command, the output is the Linux command. We'll map it to this series of prompts, the system prompt being this same thing that we've been talking about, translate the following request. The user prompt is whatever the English language query is, and then the assistant prompt would be what the output is expected to be, the bash command, the Linux command. So we'll translate all that to a new data set for training that's ready to be ingested by the training pipeline. TextAI has its own Hugging Face trainer pipeline, which is able to use any model on the Hugging Face Hub or local and fine-tune it or train a model from scratch. It's a very powerful pipeline. The link for that is in this notebook. I encourage you to take a look and learn about all the options. But for this notebook, we're just going to fine-tune Qwen 6b or 0.6b. With that same training data set, the task is language generation. We'll keep it to a small maximum length just to limit memory. We'll use floating point 16, relatively small batch size, and then we're only going to run this on for one training epoch. So runs, you can see the results here after each one of the 50 steps, and we're getting pretty good training loss. And it took about a minute and 12 seconds. So very quick. I'm running on a 3090, but for most hardware, we're not asking a ton out of this. You could certainly change some of these parameters, can be faster. You could run lower. You could quantize the model. But given we're only dealing with 600 million parameter model, I just ran the base trainer. And I'm doing everything in memory. If you wanted to save this model, you would just set the output directory. And once again, if you go look at documentation for the HF trainer pipeline, you'll be able to learn more about how to do that. So next, let's just see how the fine-tuned model, which is the model in memory, works. So we'll load it once again. Instead of loading the base model, we're going to load the fine-tuned model, and we're going to pass a series of prompts to the LLM. It's the same that we trained on, but this time, let's say, find the number of logged in users. And now, instead of a given PS-E, it's giving you who, which is going to list all of the users logged in, and then it counts it. So that is the correct, there certainly is multiple ways to do things, but that's one correct way to count the number of logged in users. List the files in my home directory. And then you see here, it's listing the files in the home directory. Zip the data directory with all of its contents. Zip-r data.zip, and then the data directory. And all these examples are using the exact same system prompt and user prompt as we trained, but we could actually just pass a text string which will wrap it as only a user prompt, and it works pretty well. Calculate the total amount of disk space used for my home directory. Only print the total. Notice that it's calling the DU tool. It's given human readable, but it's also passing in the summary option for the home directory here. So, pretty impressive for a couple thousand training examples, and not even a couple thousand, about 1,000 training examples. And then, it goes from not really working at all to, for all the use cases we tried, working pretty well. So the idea here is that, instead of trying to find some model that could do everything great, you can certainly export data. You could go to a large language model, one of the online API versions, and build your own distilled data set and train a very tiny model like this. If you have your own data, you can do it. It really depends what you have access to, but the idea is you're able to take a knowledge from either yourself, your business processes, or a larger language model and distill that down in a tiny LLM. Now you're dealing with something that could potentially just run on a CPU even, or certainly a smaller GPU. You could, things are going to come back faster response times. You can run on a single device. You're not talking about having to, load on, 2 or 3 GPU machines. So this certainly is going to save money, it saves time, and it's an efficient way to do inference from a local standpoint. Hope this was helpful. Have a great day.